Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. In today's session, I'm going to go over radical functions and uh, so rational exponents, like when the exponent is not an integer. Oh, I'm sorry. So for exponents, I already have few sessions in Algebra 1. So if you want to a quick brush up like of exponents, you can check that in the Algebra 1 playlist. However, maybe I will write here the most important ones. Is that if you have two bases with different exponents multiplied by each other, we already know that we add the exponents, so you get x raised to the a plus b. Meaning if we might multiply the same base with different exponents, we add the exponents, and of course, since the opposite of multiplication is division, then if I divide that by x to the b, the opposite of addition is subtraction, so I get x to the a minus b. Next, if I have x to the a and then the whole thing raised to the b, notice I didn't say this is not the same as to say x to the a to the b. No, that's not equal to that. X to the a to the b, meaning, so for example, if I say x squared quantity cube, that equals x to the 6 because x to the a raised to the b equals x to the a times b. But if I say x to the 2 to the 3, I have to do 2 to the third power, which is 8. And if I had another number, I would raise this to that, and then 2 to the product, and then I say x to the 2 raised to the 3. So they are not equal to each other. Be careful. You have to use the parentheses if you are using, something like that. And of course, the opposite of exponent is the radical. So if I have the bth radical of x to the a, again, this was multiplication, so that would become division, a divided by b. We also said that x to the 0 equals 1. And you can't have a negative exponent, a negative answer, whichever exponent you use. So even if you use a negative exponent, like if I say, what is x to the negative a, that basically is 1 over x to the a. Okay, so even if a is negative, I bring it down as positive in the denominator, and 1 over any positive number would be a positive number. So you cannot have a negative answer, even if you use a negative exponent. If you use a negative exponent, or if you use an exponent and you get a negative answer, it means you are working now with imaginary numbers or complex numbers. And vice versa. So if I have something like that, x to the a minus x to the 1 over x to the negative a, that becomes x to the positive a. So I can move the exponent from numerator to denominator and vice versa by simply changing the exponent. Is there anything else worth mentioning here? I don't think so. If we remember something along the way, we'll jot it down. Of course, x to the 1 first power is x, but that's not worth writing. Okay. So now let's look at the worksheet I have. There are like 12 or 13 questions. I think we can make them, solve them all because they are easy. The first one really doesn't need anything. It's a cube root of 64. I told you before, you should remember these as you remember your multiplication table. So squares and cubes should be easy. So you can say 1, 4, 9, 16, 25, say up to 10 even, that's enough. And for the cube, same thing. So you get 1 cube is 1, 2 cube is 8, 3 cube is 27, 4 cube is 64. So the third power of 64, the real roots, and you say, What do you mean by real? Yeah, because they are, notice when we say a cube root, we will have three answers. One of them is real and the other two will be imaginary or complex numbers. Okay, we'll talk about that when we go to complex numbers. Simplify 50th root. Oh, I saw that. I just saw that. Oh my God. So here, B is 50 and A is 50. So the answer is X to the A over B, 50 over 50, which is 1. So that, of course, I wrote X because I wanted to say if I have the 50th root of X to the 50, I say it equals X to the 50 over 50, which equals X. So this answer is simply 20. Instead of X, I have 20, right? We don't need to do all of that, but you should recognize that shape. The fourth root of u to the 8 times v, oh, okay, I have to separate them. So I get u to the 8 over 4, which is square, times v, 8 over 4 is square, w square x square. Okay, so that's the simplification. Um, by the way, you could say, oh, what did I get? Yeah, it's okay. So next I'm going to multiply. So when you multiply the numbers together and then the radicals together. So I have 13 times 11 is 143. Of course, you know how to multiply by 11, right? And the square root of 3 times the square root of 5 is the square root of 3 times 5. Because that's not a rule of exponents, but we can say that if I have the nth root of a times the nth, where n is any number, of b, it's the nth root of a times b. And same thing, if I divide it, would be a over b. Uh, and then, so this is the square root of 15. Divide. When I divide the numbers first. So 15 over 5 is 3. And then so 3. Root 105. If you see that 105 is divisible by 5, right? So if you divide by 5, you get root 21 times root 5 divided by root 21. So these cancel and you get 3 root 5. Very simple. Now, when you have radical in the denominator, the best thing before you start is to multiply by this radical top and bottom. Because we don't like irrational denominators. So that would be 3 square root of 21 over 21, because square root of 21 times square root of 21 is 21. And you can see 3 and 21 can be simplified by 1 over 7, and the answer would be square root of 21 over 7. Alrighty, go to number 7. I can simplify from the get-go. 15 over 5 is 3. 3 and 12, this would be 4. Negative times positive is negative. And then square root of 25 is 5. Right? And you can simplify like that. 105, we just said it's the square root of 21 times the square root of 5. Oh, came here. I just want to show you what we have in the numerator. So the numerator, I have 3, and then I broke this into those, and then I have another root 5. When I go to the denominator, I have square root of 21 times 4 times 5. Now, 21, square root of 21 and square root of 21 cancel. Root 5 times root 5 is 5. And 5 over 5 is 1, and you get negative 3/4. Okay, what do we have after that? Oh, do we have something else? No. Now, oh, number 8. For some reason, I thought there was something here. Okay, I have root 12, root 3, root 3. I cannot add them up because they are not the same radical. But I recognize that square root of 12 is square root of 4 times square root of 3. But square root of 4 is 2, so you get 26 root 3 plus 2 root 3, that's 28 root 3, minus root 3, it's 27 root 3. Okay? Now they are the same root, I can add them up. 26 plus 2 is 28, minus 1 is 27. Here, I have to use FOIL, right? So I multiply 1 by 3, I get 3. 1 by negative 3, negative root 3 is negative root 3. 3 times positive root 3 is 3 root 3. And root 3 times negative root 3 is negative 3. So the 3 and the negative 3 cancel, and you get 3 root 3 minus root 3 is 2 root 3. Again, if you have a calculator, you can check your answers. So if we pick few of them, for example, I don't know, maybe the last one we did, if I say, oops, if I say 1 plus the square root of 3 times 3 minus the square root of 3, I get 3.466, whatever. Okay, then I multiply 2 by root 3 and see if I get the same result. Yes, I did, right? So I know that. What about this one? Of course, that's easy. What about this one? 15 times the square root of 105 times negative 3 square root of 5. Oops. Oh my God. I forgot to. Times negative 3 square root of 5 divided by, and I open parentheses because I've seen people don't do that. And if you don't do that, it will just divide by this number and then multiply by the next. So you have to, excuse me, 5 square root of 21 times 12 square root of 25, which is 5. Let's see what we get. We get negative 3/4, negative 0.75. So checking is so easy. Yeah. When you get a denominator that is not rational, but it's not like root 21, so I multiply top and bottom by root 21. No, it's root 5 minus 4. So what I'm going to do is to multiply by the conjugate of that. What is the conjugate of that? It's the square root plus 4 over the square root of 5 plus 4. Do you see the bottom is a minus b times a plus b, which means a square, which is 5, a square, which is 5, minus b square, which is 16. And 5 minus 16 is negative 11, and negative 11 cancels with negative 11, and you get square root of 5 plus 4. Okay? Write this radical in the rational exponent form. Well, we know that if I have this number, it's the bth root of q to the a. So it's q to the a, which is, well, I should say 3/2 divided by 3. So it's q to the 1/2, which is square root of q. So q, but they want it in rational exponent form, so it's 1/2. Meaning you divide 3/2 by 3, you get 1/2. 3 and the 3 cancel. This one, what is the 7th root of 128? It's 2. So you take the numbers first, then the variable. You know that 2 times 2 is 4, that's 2 squared, times 4 is 16, that's 2 to the 4th, times 4 is 64, which is 2 to the 6, and then 64 times 2 is 128. Again, so the powers of 2 are easy to remember. You can go to probably 16 or more, but again, this is something you should know just by looking. So 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048. You can at least go to 1024 so easy because that's a byte, like when you say kilobyte, the kilo here is not 1,000 as we usually use, it's 1024, which is 2 to the 10th power. And if 2 to the 10th is 1024, then, you can go backwards. Anyway, even if you don't do it, use the calculator. I don't want to go into that. This guy is the same as that guy. Y to the 21 divided by 7. 21 over 7 is 3, so y cubed. And the last one, write f squared to the 4 as a single expression. We just said it here. So if a is 2 and b is 4, a times b is 2 times 4. So it's f to the 8. And basically, that's it. I think we didn't talk about adding, subtracting functions, and so I will think I'm gonna defer that for now. And next session, I will go over logarithmic functions because we did the exponent, and the inverse of exponent is logarithm. And I think that would be it. If you have any questions on this worksheet, let me know. Otherwise, I wish you all the best, and I'll see you soon with logarithmic equations and logarithmic functions. Thanks. Have a great day.